I work for Warner Music Group, and I'm going to moderate this panel around AWS APIs and OpenStack, and probably quite a few other things I'm sure we'll end up going into as we get started. So next to me, this is Randy Bias, CEO of Cloudscaling. I've actually known Randy for a while. He's a pretty nice guy, although some people might disagree with me on that. This is Nati Shalom next to him. He's with GigaSpaces. Nati's been around for quite a while, and I've watched his GigaSpaces has grown and done all sorts of interesting things, and now does a lot of interesting things with Cloudify. And this is Alex Freedland, who, this is the first time I've met Alex, is with Mirantis. He's the CEO of Mirantis. Hope I got all that right and didn't screw anything up. All right, fantastic. I'd also like to point out a tiny bit of disclosure. While I'm not directly affiliated with OpenStack, my wife is. She's with Piston Cloud, another OpenStack vendor as well. So I think we should get started with maybe talking about more of what is happening with AWS and the APIs and kind of the connection with the enterprise, and kind of maybe what we're seeing and in some cases not seeing. So I'm sure this will lead us where we need to go. Who wants to go first?
I got handed the mic, so I guess it's me.
There you go.
Is this thing on? I hope so. All right, so I just want to clarify a couple quick things. I mean, part of the reason we're doing this panel is because I created a kerfuffle with a big blog posting I did about embracing about the OpenStack community embracing Amazon, and somehow that's been misinterpreted into OpenStack embracing the AWS APIs. And I think the problem with that misconception is that the AWS APIs, or at least the EC2 and S3 APIs, are already in OpenStack. So that's never been my position. My position has been that because Amazon's the largest public cloud and has this huge ecosystem, that it's in the benefits of the OpenStack community to see Amazon as a friend and as a partner in building cloud computing and making the pie bigger for everybody and driving adoption, not to see them as an enemy. And that certain subcomponents of the OpenStack community, and I'll just go out and name names, namely Rackspace, among some others, like to draw a picture of Amazon being, evil, right, or the enemy, or VMware is the enemy. And I just think that doesn't make sense. It's counterproductive. And what we're all trying to do is make OpenStack succeed, and that means there needs to be many flavors of OpenStack that support a bunch of different APIs, of which AWS compatibility is one.
So I think that the main point, if I want to kind of frame what the discussion, at least the way I interpret it, is that really we're talking about the portability of OpenStack to other clouds, and I think that one thing that came out pretty good from Randy's post is kind of the raising the red flag. Hey guys, you might be going in a certain direction that is not necessarily the direction that you actually want to go, which is the lack of portability. You're looking at Amazon as a competition. The thing that I felt that requires more discussion is how do you, first of all, what is portability? Portability with what? With which cloud? Is that only Amazon, or is that also Google, Azure, all those type of things? In that case, while we're zeroing into an API discussion, where the actual portability aspect might be a more broader aspect. So that's kind of the point that I wanted to take in terms of the discussions. Portability is the right thing, but then let's define what is portability and what's the right way to deal with portability.
I was going to say, Alex, you have to have an opinion after all of this.
Yeah.
You bet, you have to have an opinion. So this is, for those of you who might have followed this is round 3 of the debate. And I think, for this to be a debate, we have to have differences of opinion, otherwise it's going to be boring. So Boris lost round 1 because he basically said there is no difference of opinion, and everybody said Randy won. So I have to have something. So I think we're all agreeing that we're all trying to make OpenStack part of the cloud computing ecosystem, and a very, very important part for that matter. And that means it's all about the customers. What does it take for customers to be able to use whatever the option they want in the most easy way? And when Amazon becomes a dominant ecosystem, it actually builds the market. And one of the reasons for OpenStack to be there is because not everybody wants to be on Amazon. So the speed of growth of OpenStack will be very much tied to Amazon. So we're going to love Amazon. But then the question becomes, for us as the community, what is the priority? When do we actually worry about the APIs and compatibility, and what are the things we need to do today versus tomorrow to make sure that OpenStack is actually a good competitive ecosystem so that customers can really take advantage of it? Because today, lots of people are talking about it, but how many people are truly taking advantage of OpenStack is a question. So if we can solve that problem all as a community, I think our companies are going to be successful, and OpenStack is going to be successful, and cloud computing will be successful.
I think I have a question then. If we follow this path of Amazon being the dominant player and we embrace Amazon's APIs, I think there are a couple of questions, at least, that I would ask. The first is, which APIs, as Amazon continues to grow their services and creates new services, which then of course have new APIs. And so at which layer do you, or where do you stop with the APIs? I mean, currently OpenStack supports the equivalent of API compatibility for some of Amazon's APIs, not all of them. Obviously Amazon's free, although they would pay quite a penalty from the community to change their APIs. And so as you do that, you take on risk, as do you take on risk with any of these APIs that you replicate. So we have to be careful about which APIs and for what purpose do you gain by keeping compatibility. So you have to keep that in mind, at least that's what I think.
So I don't know that we need to pick where we stop, right? I mean, it's really the community as a whole will pick where we stop. Why should I draw a line? I mean, you look at OpenStack Heat, which came out of Red Hat. It's a rewrite of CloudFormation. It's got the CloudFormation and the CloudWatch APIs in it. So, there's a whole bunch of AWS APIs in the OpenStack ecosystem now. I don't see any reason to draw a line. I mean, the community will fast follow as it fast follows. In terms of the API stability, the Amazon APIs in OpenStack have been the most stable set of APIs, at least for EC2, above and beyond OpenStack's native Nova APIs, the Rackspace APIs. They've been far more stable, and part of the reason is that if you look at Amazon's history to date, so far they generally don't kill backwards compatibility because they've got a massive ecosystem. So they can't really do that easily, and they're not going to do that easily. So it's a little bit of a red herring to go, if we follow the AWS APIs and Amazon can just change it willy-nilly and we're at their beck and call. It's like, no, that's not really the situation. They're not going to change it willy-nilly. Let's talk about things that are real, because that's going to break their own ecosystem. Yes, they're going to add stuff that is in there, and they're going to know about it in advance of OpenStack, and OpenStack would always be fast following. But on the other hand, the advantage is that we get to allow customers who are on Amazon today to get off onto OpenStack very easily, and I think we all want that. And we all want to enable hybrid cloud, and so how are we going to do that unless we have great support for as many of the AWS APIs as makes sense?
Yeah, the problem that I have even with the question is that we immediately jumped into the assumption that what we're doing from compatibility is AWS API, and then which API do we choose, and so forth and so forth. And that line of thought assumes that portability equals interoperability, and portability only to Amazon. Now, if you broaden that discussion and think about portability, which I think the point that came out right in Randy's post, what about Google? What about Azure? What about why should we limit ourselves into AWS? And if in that case, why are we talking about AWS API? Why are we not talking about something that will actually work with all of them? Should we do a bridge per API, per cloud? And that's kind of another question that comes immediately out of that. What are the options to deal with portability? Is that only API compatibility? API compatibility is one option. But again, if you look at different APIs that each cloud provider have, going with the path of API compatibility means that you need to have a bridge of API and you're going to do some chasing of each of those vendors to maintain compatibility. So if you're only looking at compatibility or portability in Amazon, then API becomes something more sustainable. But if you look at that in a more broader context, it's not necessarily that sustainable. And I'm not sure that we need to narrow the portability only into Amazon. So I think the discussion should be first, what is portability, and do we mean portability only to Amazon or to something broader? Second, what are the options for doing portability, and whether API compatibility is the right options. And there are more than one option to do with portability, and I've been dealing with portability for 3 years. So I think the discussion should start there in my point.
So I want to ask you a question, Nati, since you've been dealing with the portability issue, jumping in, taking Dave's job. Don't shoot me, Dave. What I posited before is that it's about more than the APIs. It's about the architectural behavior and sort of the semantics and the semantic behavior. And so what I mean by that is, like, if I spin up a VM on Cloud A and I spin up a VM on Cloud B, and this one takes me 5 minutes and this one takes me an hour, the problem is that the app layer or the portability layer, the abstraction layer, doesn't make allowances for an hour to spin up a VM. Things break. And so, it's not enough to copy APIs. You actually have to copy architecture, right? That's why Doblik, which runs on Android, is just a complete clean room rewrite of the JVM, but it behaves and acts in almost the same way. I mean, what are you finding the problems are with portability at a non-API architectural level between clouds?
Yeah, so that's a very good question, but actually that implies why you can't put just a layer of API, for example, of Amazon, because people assume certain behavior when you do that. And if the cloud happens to spawn a VM in not 3 minutes or less than 3 minutes, but 10 minutes, and you're still using the Amazon API, then you might actually get a completely different experience, which is the behavior. Now, back to your question, I think that the portability aspect, or the concept of portability in general, and if you follow the history, because I don't think that it's unique to OpenStack, that question. We always use the parallel of Linux to describe what Amazon is, or what OpenStack is doing. And if we look at Linux and how Linux dealt with that, then there was an attempt to do kind of API compatibility. Everyone knows Cygwin. Everyone used Cygwin here?
Sure.
Have you used it in production as well? Okay.
Great man.
Okay. And does anyone heard about Windows? Windows? Linux tried, and you've been the one to use it? Okay, so we got one to use it. So I'm saying that the history shows that, yes, there is a dominant player there was. In the case of Linux, it was Windows, but you don't necessarily need to have the same API to actually not just win the battle, but also maintain portability. Another example that is more recent is Android and iOS, and you mentioned that right now. When Android came out to the world, iOS was a dominant player. They could have picked up the right strategy, or one strategy, and actually there wasn't too many players like in the cloud, to say let's embrace the iOS API, and that would be the strategy. Yet they didn't, and still you maintain portability. People do write applications to both platforms, and they've been successful. And Android has been actually very successful taking that strategy. So coming back to your question, I think that if you look at portability, it's really how do you deal with the scope of change? And the basic idea is not to create a leak abstraction. It's not to hide the differences, but minimize the scope of the differences. And that's the core thing. You know that Amazon behaves that way. I'm not going to hide that. I'm not going to create an API that tells you that now Google looks like Amazon, or VMware looks like Amazon, because they're not. But I'm going to minimize the change. And we can have a discussion how you minimize the change, but that's kind of a more philosophical discussion and practical discussion around that.
Well, I happen to be very close to where Nati falls here, but I think we're putting a cart a little bit in front of a horse today, because before we talk about interoperability, we need to make the horse to work. And today, we have probably the largest number of live customer engagements and production customer engagements of anybody in the OpenStack ecosystem. We do more than 60 production implementations of OpenStack for all kinds of customers. And I must say that the driving force for this has never been somebody trying to kind of leave Amazon and go to OpenStack. That's not why they do it. They do it for diversification reasons. They do it for internal politics. They do it for strategy reasons. And right now, that is the driving force. And so what we're seeing, the issue is today, is the internal engineering of how OpenStack is built isn't quite ready for prime time. And for a small setup, maybe of 100 servers, it kind of works, but try to put it on 500 servers as a trunk. It's actually a big problem. When you look at how it's engineered, you look at the problems you have at the scheduler level, and what happens if you start spawning virtual machines, and suddenly the scheduler becoming a bottleneck, and many things of that nature. And the technical committee, which is not today dominated by a benevolent dictator, doesn't have a very strong opinion as to how this is done. So I think the priority that we ought to take as a community is to make OpenStack work like a true cloud ecosystem. And there are different ways to make it work. One is what Randy's company has done, and they're known to be very, very strong engineering guys, and they've built a version of OpenStack that is probably engineered very, very well. And that's a solution. The other solution is, how do you make the trunk be engineered better? And ultimately, for mass adoption, the latter is probably a more important problem for us to solve as a community, because when we talk to a lot of customers, they're interested in innovation coming from open source, not a specific version of somebody else's innovation. And so if we can solve that problem and it's engineered right, then the problem of interoperability will become a real problem to be solved, and it will be solved at multiple levels. One level is we have people like Rackspace and others who will create layers above and will go deep inside the ecosystems and create a solution. There'll be others that'll do it at the API level, and what I offered that Randy might want to consider is take a project inside OpenStack called Amazon API as a project, and just basically write it and own it, and be the go-to guy where everybody wants API level compatibility, and the community will embrace it right away. But I don't know that for our success as an ecosystem, this is the #1 priority. That's where I sit.
Yeah, that's great. I don't think I ever said it should be the #1 priority. I just said we shouldn't demonize Amazon, and it's been pretty clear in the posting if that's the case. I just want to kind of rebut a couple of things. I might have done a few OpenStack production deployments, as you know, and working with Mirantis on a few of those. And we are seeing people come off of AWS. That's a very common use case. I've got about 4 startup customers right now, one of whom is spending millions of dollars a month on Amazon Web Services, and they want to cost optimize that. They want to run it on OpenStack, or at least a fair bit, and they want to run a hybrid cloud. And one of the world's largest retailers is about to go with us. And they've got thousands and thousands of virtual machines, M1 extra larges on Amazon that they want to pull back. And what's happened is that you probably have all noticed that over the last 15 years, software companies, new startups have changed dramatically. They don't actually buy their own hardware anymore. They all start on Amazon. And so what's key about that is that people are still growing their enterprise businesses through acquisition. So Symantec's $6 billion of revenue, half of that is SaaS. Half of it is SaaS.
You should qualify. Many startups start on Amazon, but not
many,
all. If
many
you're doing
startups.
hardware or you're writing, say, systems management for
Software
hardware,
companies.
right? If you're pure software or you're focused on SaaS,
Correct.
then you go on AWS.
Absolutely. And so there are great reasons to want to pull people off Amazon Web Services. So I think it's a little bit of a mischaracterization to say that use case doesn't exist, because I know that it does, and I can prove that it does. And then the second is that I think we all want OpenStack to be better, right? I mean, the point of sort of making the engineering and trunk better is great. Like, I'd love to do that, right? I mean, there's stuff that we could push back, that people could ding us for that we haven't, and I think that's fine. And over time we'll push that stuff back. But the problem is that the community strength right now is also its weakness. It's about inclusivity and it's about innovation. And so there's so many people trying to tug it in all kinds of different directions. I mean, look at everything that's in there, all the different network providers and storage providers, hypervisor support and bare metal and Linux containers, and just you go on and on and on and on, right? It's hard to put good engineering into that, because I might make a design decision for LXC or bare metal that makes no sense for Hyper-V and ESX, right? And there's nobody to break those ties except for the PTLs, right? So I like to look at OpenStack as being like the Linux kernel, right? Do you download the Linux kernel and compile it from source? Maybe some of you do. But, the majority of us don't, right? I mean, the majority of us go get a baked distribution, right? Downloading OpenStack's not like downloading MySQL and turning on a database. It's like downloading the Linux kernel, and then you got to compile the damn thing, add a user LAN, put in an installer, like figure out how to support different hardware. I mean, it is a huge, huge thing. So I think it behooves the community to actually embrace the product companies like us that are trying to bring to market a specific flavor of OpenStack, an AWS, Google Compute Engine flavor. I mean, hey, that might not win, but there are some customers who may want that. Somebody else may go do an HPC OpenStack. Somebody else may go do some other, I was talking to the VCE guys. They want to put OpenStack on the vBlock, right? I mean, that wouldn't have been my first choice of where to put OpenStack, but if somebody wants to put on a vBlock, power to them, right? But I just think it's really hard at this point to sort of say, let's put all the great engineering in trunk, because a lot of that is going to be contentious. I don't think it's clear. But I can engineer for a specific use case, and I can make that use case really great. And that's where I think that we want differentiation in the ecosystem. Oh, wait.
I don't need the mic. I do have one question. If we go down that path, doesn't that mean that trunk takes forever to evolve, and eventually if you have enough of these competing interests, you end up with something that starts to lag further and further and further behind? Doesn't there need to be something that allows it to work in parallel so that many of these needs can be met at the same time? And maybe that is some specific deeper focus on solving specific problems, including, by the way, different companies may be focusing on API compatibility for different cloudy services. I agree with your comments, Nati, that it might be better if we avoid trying to do pure abstractions. I know I certainly tried to do that a long time ago with hypervisors. It never works. You can't abstract Hyper-V, KVM, and VMware to look the same. It's impossible. You end up getting with these nuanced behaviors that become impossible to replicate on the other. And if you hide it, everything that depends on it fails. So I agree with that. But what you can do is create leaky abstractions that let you do enough things to get some jobs done. And the question is, what are you trying to get done? Are we focused on management and automation tools like a Rackspace kind of thing, where you're doing deployments and things across these, where I need deep Amazon EC2-ish compatibility? Or am I focused on applications that actually run inside and on top of these the VMs and such that are really being built by OpenStack, right? Ultimately, you want to run applications on this damn thing anyway. If you're not running apps, why'd you bother?
So I'll break the answer into three parts. One of them, when we talk about portability, what are the scenarios that we're talking about? So usually it will be switch, like the customer that you probably mentioned. I'm paying too much to Amazon and I'm going to do a complete switch, which means that the portability is a one-off effort. There is the hybrid cloud scenario in which it's a continuous effort. I always want the two to work. And the same goes with DR, which I'm going to switch only when something fails in one cloud and I want to manage that. So those are the, I would say, three difficult scenarios where portability comes to mind. Obviously, the first one is kind of, in my view, a narrow case, because we do look at the future as more of a hybrid cloud. So portability is going to be more continuous kind of effort. Then, to your questions, what are the options for maintaining portability? One option is to do API compatibility, and I mentioned one problem with that is that if we think about only Amazon, that's one scope. But if you think about Amazon, Azure, and Google, and VMware, then it becomes a completely different scope. Just doing that for every cloud. And then the question is, what is the second option? Is there a second option for API compatibility and still maintain compatibility? And yes, the Rackspace approach, which is templating model, is also a valid approach. And there is advantage to that, and there is disadvantage to that. There is no, by the way, there is no solution that is 100% guarantee that portability would be a zero effort. The difference that I think people have with that approach, and I heard Randy talking about that a little bit, is that so the main concept about that approach with the templating approach, which I think Heath is actually going in that, is that you're basically trying to minimize the change. And let's talk about minimizing the change. When we're talking about application, the application code is not really specific to Amazon. I'm writing to MySQL, I'm writing to Tomcat or to
Simple
Ruby.
DB
Or-
or RDS
Well,
or
if you're writing to
Dynamo.
simple DB, then you're doing something wrong. But most applications were not written to Amazon API, and I don't think that most of the applications are reading to those proprietary services. Most of the applications are reading to middleware that would run pretty much the same on Amazon or would run on an operating system. Most of the things that when we're talking about portability are the things that deal with how you start a machine, how you create the network, how you create security, how you plug in load balancer, and those type of things. This is the issue.
Well, so we have two different, this is where I was originally going, where we have two different types of APIs. We have, how do I make the systems work, and how do I drive the systems? And then there are the APIs for things that are not the systems, but things that your application might use, like a simple DB, like an RDS, like go through the list of what I would call up-level things that Amazon and frankly, ultimately, I think other things offer as APIs. And so, in my view, you have the application that might be consuming an API, and then you have the things driving the machines.
Right, and I think most of the portability is not in the API because Elastic Cache is Memcache, RDS is basically MySQL, and other databases. The Elastic MapReduce is Hadoop. So most of the services are actually services that are not specific to Amazon or to any cloud.
But if I write my stuff for Elastic, if I write my stuff for any of the Amazon services, it's not like I just literally point it over to
Yeah.
the
All I
other
said is that
networks.
it's a narrow case in my view.
Sure.
Out of the, if
But
you
you
look
still
at all
have
the
to change
workload,
that.
yeah. But if you look at the workload that is running on most of the clouds, most of them don't use those proprietary APIs. Most of them, the problem is really dealing with the network, security, load balancer, image, and all those type of things. That's really where the portability, I would say 90% even of the portability problem exists. Now, if you could abstract that, and I'll describe how to abstract that, then you minimize the problem. And when I'm saying abstract, it's basically saying that if you have tens of applications, if you could put the change or the things that are specific to Amazon in one place, then you minimize the change. If it's all scattered around the 10 applications, then it's a big problem. So just by being able to take all those 10 applications and say, when you work with Amazon, work with the Amazon API, when you work with OpenStack, work with OpenStack API, but there's going to be one place in which I'm going to have that details and knowledge, then the effort by definition is 10th of the scope that it was otherwise. So just by doing that, we can minimize the effort. Now, if it's a one-off effort, if it's a switch, taking that plug-in and just changing it in one place to another one, that's not such a big deal. Even if I rip it and replace it.
I think you're oversimplifying. I mean, there are ways to create portability and interop, but it's just not exactly that simple. I'll give you a very clear example. You build your application on Amazon Web Services. You use Chef or Puppet to basically, do all your automation. You're using the classic networking model. There's one network interface on every VM, and Chef and Puppet use an algorithm to determine what their IP is, the IP of the server.
My IP.
So you can, my IP, yes. Yeah. So they use that to basically bind applications and configure applications when the configuration management system runs. You take that app and you move it over to Rackspace Public Cloud, which has 2 network interfaces per VM. Now, which one gets my IP? Is it the front-end network, which you can attach public IPs to, that behaves like Amazon, or is it the back-end network? You get non-deterministic behavior. You go to a VMware cloud, and you can have arbitrary numbers of NICs attached to a VM when you spin it up. So you can do a certain amount of abstraction of APIs, but that's not as important as getting similar semantic and architectural behavior when you're actually calling the APIs, right? Because all APIs do is initiate a behavior.
Yeah, and I would say that putting the Amazon API on top of it doesn't solve that problem.
That's right.
It's going to be the same problem. And all I'm saying is that don't hide that there is a difference in the behavior.
Right.
And when you do the switch, especially if it's, oh, sorry.
That's
I'll finish just, but if you're doing if the problem that you're targeting, for example, right now is a one-off switch, it's a very small problem because you're basically going to change the API when you move to OpenStack into the OpenStack API, and that's fine. And if it's centralized in one place, that's not such a big effort. If you're doing it continuously, if it's stale, if it's one place, it's not such a big effort. That's what I'm trying to say.
So to this effect, I mean, there was a lead-in that I think kind of it's a little bit of a religion, but it's important to how we think about this whole ecosystem, and that it's close to what Nati has said. And those of you who follow community heard the work that's been done in Oslo DB and the Havana release. How many know what I'm talking about? Okay, so there was actually a fairly sizable battle that Mirantis guys led to actually get database code, centralized in one place, so that there is a central way you can handle certain things and it wouldn't be spread all over the place. And that's an architectural thing that you have to have, so your code is maintainable, so that you have scalability. And for upgrades, it's a foundation to get the upgrades going. So why is it that we felt that this is an important initiative that we wanted to spearhead, because nobody else was doing it? Because without that, you can't have your trunk be a powerful enough version of OpenStack. And why are we doing that? Because there is a whole bunch of customers that we're talking with, and we have a lot of smart engineers. And by the way, I must preface this, I forgot to say this, and it's, gotta give credit where it's due. The reason we're actually in OpenStack as a company is because the first project we ever got was the one that Randy gave us for internet, right? So Randy is kind of, is a father figure for us.
I created my own worst enemy.
I don't know, it's the compliment.
It's the joker.
I love competing with Mirantis.
Well, I don't think we're competing. I think there's enough for all of us.
Oh yeah, but we're still competing.
Well, some deals maybe.
There's
to
enough
the
for
wall.
all,
Peace to the wall.
and we're competing.
All right, that's fine. So we'll compete with
Competition.
But competition,
Exactly.
yes. We do this with Dell too, right? And we help them to build a competing product. So it's just the way it works, right? And as a result, we can have a viable conversation about how to make both our products work better together.
Absolutely.
Plenty of room. There you go. So the reason we're so adamant about doing this is because we have a lot of engineers who come from a commercial company background. And what that means, a lot of engineers in the room, you look at somebody else's code and you go, that's not done well. I do it better. And then you put the smart guys there and they actually do a great job. And then you go to our customers and they say, who embraced it yet? How many people contributing and what is this thing? Oh, it's working great, that's wonderful. I don't want it because it's not part of trunk. And by the way, I don't even want to talk to you unless it's part of trunk. And if you can't do it, just give me some smart engineers, I'll engineer it myself. Or something like that. And there is not just your technology savvy customers, but we're finding that the enterprise customers are starting to say that too. So that for more people, it's actually more important that they're not buying a specific solution to a specific problem, but rather standardizing on something and they're trying not to see it splitting up. So where I agree that there'll be plenty of use cases where companies can create a spot solution for that use case and do a very good job, and it's a viable business model. Ultimately, for OpenStack to succeed, it needs to be agnostic and very, very good. And quite frankly, that's what we're trying to do. I know that's what Red Hat is trying to do. These guys have a platform agenda, we don't, so we can collaborate with them and compete with them as well. And they even invested in us, as did Dell, for the same reason, because Dell has a platform agenda and we don't, and we can help each other. But ultimately, if we can force the standardization, make OpenStack better, spend time in the community, and we're, from being nowhere a year ago, we're number 4 today in the community for Havana Core, number 2 for in incubated projects, and number 1 on StackForge in general. So it kind of shows that we're committed to.
So Alex, so assuming that you're correct, how does this get solved? So you've said that there are problems because you can't get things into trunk and that there are all of these issues. So the question is, okay, if we all agree that that's the problem, what is the solution to the problem?
I think we, the people active in the community need to do a much stronger job aligning around the technical committee and driving a lot more architecture. And people with influence like Randy and the Piston guys and the Nebula guys and the Mirantis guys need to agree that the GigaSpaces guys for sure. We all need to agree that the architecture of what the product is, there needs to be a centralized architectural team that will agree. And I must say that when you talk to the people in the community, in the technical group, it's all meritocracy based. So it's actually easier to get them to agree on things if you frame it right. And I think we need to actually spend a lot more time doing that. And that's your answer.
We have a question, yes.
Yeah, is that going to matter if everybody gets together and makes decisions like that and gets on the same page if Red Hat doesn't? They control most of the details at this point. If they don't like something, it may not get blocked, but it may get blocked in code review, for instance, and things move very slowly.
We haven't seen any of that from Red Hat guys. Yes, they do control it, but like I said, it's all meritocracy based. So we work with, with every core project, and we've never seen an issue that they don't like it for whatever reason. So long as you have good merits of why you want to do it, and you kind of talk about it before and sell your ideas, as community does it, you have no problem getting anything in.
Another question, yes.
What about security?
What about security? Is that correct? Yeah.
The security. How secure the system?
If the question is
How secure
general,
is the system?
It's a very general question.
Yes, it is.
It's a general question. It's hard to answer. The nutshell is that it has a long way to go. Being nice, and there are some serious problems with the security in the system. People like Eric, who's on my team, are working on. They worked on what was that security guidebook? Was that what it was?
Yeah,
security handbook?
we did the OpenStack security back.
Yeah, so there's some best practices evolving about how to deploy it securely. There's a long way to go. I did security full time for 7 years, and then I got a little bit jaded with the whole thing. The reality is that whether people like it or not, security always follows business value. So it's important, but it's of secondary importance. So I think as we have more and more OpenStack deployments done, the pressure will increase on increasing the security. And you already see some of that with like Red Hat doing things like baking in SE Linux support to their distribution. So you'll see more and more of that, but it's always gonna lag a little bit. So expect a few years before it's like really rock solid.
And I wanted to comment to your question. I think that the risk of having a dominant player in general is always a risk in those projects. I mean, it was Rackspace before, and now it's Red Hat. Some people think that IBM will be doing it next, and so the risk exists. But I think that the structure and the diversity of players in the community is such that I think the community can still deal with that. And we have people like Randy that wouldn't let at least Rackspace do their gig. So I think there is some self-balance in the community to at least, if something definitely wrong is going, that there would be enough voices that will raise their voice and deal with that. So I think that it's a relatively lower risk when the community is big enough. That's my point.
Right, and just a quick add to this, that I think so long as customers are being adamant that they want innovation come from the trunk, and whenever you come with a good solution, they'll tell you it's great, but we don't want it. It will force us all to be on the same page. Now, how long will this continue remains to be seen. But so far, we've seen that being the case.
Yes.
So there's two main points related to what you're talking about. One is heat's very important as it's becoming kind of a way for doing this sort of high-level abstraction in a unified manner. But the other, coming from the other direction, is the concept of nailing down what OpenStack really is. And I know there's discussions ongoing with the foundation board of what OpenStack is going to be and how each of the individual distributions are going to have to line up to be considered OpenStack. I'd love to hear more about what your opinions are in regards to how that plays into your AWS API capabilities.
It's a very complex situation. I mean, if you go to the board right now and you ask people, is OpenStack the code or the APIs? You'll actually get very different answers depending on whether it's one of the technologists and software developers or whether it's one of the business people. If you talk to a lot of the business people, they tend to say it's the APIs and they don't care what's behind that API. And if you talk to the software folks, it's typically, they're all about the software. And they don't really care about the APIs, believe it or not. I haven't had any pushback from the PTLs about putting in Google Compute Engine APIs or AWS API updates. They just simply don't care. They care about the code. So it's a complex. Which one is it? I don't know. I'm tempted to say it's both, but then you're kind of in the same place we are now, which is that it's both, and you haven't really resolved anything, right? And depending on which one you pick, whether it's APIs or code, certain things become very obvious. Like if it's APIs, then why can't Ceph be part of OpenStack? It's got the Swift and S3 APIs. Why not? Why don't we just let it in, right? But if it's software, then it's a very different thing, right? Like, why is it that something like Swift or maybe Keystone or Ceilometer can be a fully opinionated stack that's not pluggable at all or hardly at all, and is that opinion right? Versus something like Nova, Quantum, and Cinder, which are highly pluggable systems. They're almost at their own leaky abstractions that can support a number of different sort of solutions underneath them. What does that mean when we do that? I mean, why is some software allowed to do that and other projects aren't? It's a very complicated issue. And in terms of how it affects the AWS APIs, I don't think it does. I think the right thing is to make sure that there are good, strong, low-level APIs for each of the projects, and then we can put whatever bridges on top of that we need. So, I'm not a big fan of CDMI, the Open Standard Object Storage Interface, but some people might want that. And if they want to stick it on Swift, hey, power to you. I don't really care. We just need to make sure it's done the way that makes sense for the project.
So I want to touch on your question about heat and the two concepts, but before that I just want to compliment what Alex was saying. I'm from GigaSpaces and from Cloudify, and we also have smart engineers, just to put the plug here. But anyway, coming back to your question, there are two, I think, concepts. One of them is the API compatibility, but we didn't discuss the templating model, which is the DSL model. And I'm going to speak about it on behalf of myself. I'm not sure that I represent anyone here in the room, but the question is really how the future is going to look like. How many people are actually going to interact with API versus templates? And that's, I think, will drive where cloud would go, and in general, I think that will affect OpenStack. So in my view, most users wouldn't want to go to API to fork, for example, MySQL or their application. They would want to say, and I'll explain even why.
Can you explain who a user is first?
Yes, so for example, the user would be the IT of an organization that wants to deploy. The user would be developers that is deploying an application.
Okay.
Those users would basically want to say, here's my application, I want it highly available, I want it scalable at those criteria and those metrics. If it reaches this SLA and this SLA, increase an instance, remove an instance, and they would want to describe not just the API, but also the behavior of the application, and just deploy it. And they would also want to replicate those definitions between one project to another, between one customer to another, even globally. And that's kind of, I think, how the cloud stack is going to be consumed over time. We're not there yet, but I think and I see more people using cloud in that way than interacting with API directly. And the people that will be interacting with API is mostly the ones who would be actually implementing the orchestrators, which is a relatively small group of users that will actually interact with that. With that,
Wait, the API.
The API, I mean the underlying API of the cloud. This is how you spawn
The infrastructure API.
The infrastructure API.
Okay.
Sorry.
There are like 18 layers of APIs
Yeah,
we're
right.
talking about
The
that are all
infrastructure.
stacked on top of each other.
The infrastructure
So,
API,
yeah,
right.
okay.
The infrastructure API. And those would be the bunch that will actually speak at that level. So if you think about it in that way, you also understand my view of portability is that we need that definition to be more standardized and more open. And the API, in my view, is anecdotal. The specific API portability. Because if we do a good job on heat, for example, and defining that DSL and making the definition, and there is also work in Tosca around that, the definition of what is a behavior, how you define a stack, how you define an application in a more common way, then you have one place in which you need to make that template talk to the right API, and you minimize the scope of that quite substantially. So in my view, heat and the things that will be around it would be the thing that will drive a lot of that direction, and in my view, that's where OpenStack should be going.
Agreed, but if I were to kind of look at the future, I think there is a formal definition of what OpenStack is that the foundation puts out, and then I think what we are betting OpenStack will become. And our bet, and my personal bet, is that OpenStack will become a full, complete stack from kind of soup to nuts. The soup part being the bottom, and will kind of go up. And we're seeing this already. That OpenStack started as core infrastructure bits and pieces, storage and compute. Now we're talking orchestration, and we're talking about control planes for Hadoop. And Savannah had their incubation meeting, and we're hoping that it will become part of OpenStack, right? But it's very far from compute and storage. It's already enabling applications, so moving up the stack, and the conversations we're having with Murana and Cloudify is along the lines, and this is a core OpenStack conversation. So ultimately, what's going to happen is it's about enabling users and users in application to be able to use cloud natively and the most efficiently. And the reason people are going to OpenStack is because OpenStack is highly configurable. It can be optimized to a specific application use case, right? And Amazon is more generic than that, right? So if you want to do that, as it becomes layer after layer native, you will use the native things and move up the stack, and it will be its own fully functional stack that will be present in every enterprise, every service provider, everything. So it's phenomenal, right? But it will grow from bottom up and more up in the application space. That's our bet.
This will be, I'm sure, a little provocative, but I don't know if I 100% agree that that's kind of the end state. I think that's a state in what ends up being more of a longer term thing. I think what we're going to see is enterprises adopt, I think we'll see them adopt a lot of OpenStack, and I think what they're going to find is until they learn that running things on a cloudy environment is not the same thing as deploying a copy of vSphere and throwing some classic 3-tier apps on it, that they're not happy with the results. And I think that most enterprises believe that cloud is you deploy a copy of OpenStack or you deploy a copy of, I don't care, CloudStack, it doesn't matter. You deploy these things and magically you're going to get this super incredible ROI. You're going to have all this flexibility that you just in no way could ever have, and it's going to be rainbows and unicorns. And I just don't think that's going to be what happens. I think I think there'll be some successes, but I think there won't be the ROI that is expected. I think until the applications are adjusted to better deal with cloudy infrastructure, you're not going to see that. And I think that there are swaths of IT people that are going to end up deploying OpenStack, and you're going to have a whole lot of developers still writing that, I've got my web tier, my app tier, and my database, and it should just work. What's the problem? I've been designing applications like this for 15 years, and what do you mean I need to do something different? No, this is the way I've been doing it, and until that changes, I think we're going to end up in a really bad spot for a few years at least, until word gets out that the developers need to change the way they do things too. And I don't think we're there yet, but I'm predicting that that's coming, and when it does, there are going to be some interesting phenomena occurring.
I'm going to agree and disagree.
Awesome.
The reality is right now is that there are people who get that. There are enterprises who get that. They're leaning forward. DevOps is a real hot button. People are trying to get their heads around it. And I've been shocked at how many of these financial services companies I've gone into over the past week while I've been here that are already on Amazon or using Amazon in some capacity. So there are definitely leaders who have figured it out. The thing that I'm going to agree with is that I think that you get a tendency for people to kind of want a cheaper vBlock. They sort of in their head, cloud computing is virtual machines on demand, right? And cloud computing is not virtual machines on demand. It's not block storage on demand. It's not networking on demand. It's a new model for IT that the internet scale guys have shown us. OpenStack is a great tool for getting there. But like I said before, you could use OpenStack to build you could put it on fiber channel SAN. Brocade's in the mix now, and they're adding fiber channel drivers and all that good stuff. So, you have lots of options with OpenStack. You can build a classic, VMware, vSphere-based approach. So I think that their expectations aren't mismatched in that you could do that with OpenStack. But I think what's happened that people don't really realize is that OpenStack, while being very flexible, actually has an affinity for one approach. And that affinity looks more like Amazon than it does for VMware or vSphere. And I'll give you an example. If you want to use ESX, and I've told VMware this so many times, and they totally just don't get it. If you want to use ESX, you've got this problem where you can't run the Nova Compute Controller co-resident on ESX because you can't load code on an ESX or an ESXi hypervisor because it's not, a traditional operating system like you would have with KVM or Xen. So now you wind up taking the Nova Compute Controller and you take it off, and if you want to control your ESX nodes directly without using vSphere, you have to run one instance of every Nova Compute Controller for every single node in your system. Oh, and then you need to make it HA, and then you need to monitor it. I mean,
So you just need more VMware. What's the problem?
so then your next step is you do vSphere on top of VSX, and then you have Nova Compute Controller managing the vSphere cluster, and it's just a cluster bleep. And so, the way that OpenStack has been designed to date, it's doesn't have very good affinity for fiber channel SANs, and you can make it do that, but it's unnatural, right? So, and I think that that's kind of where I agree with you again, which is that, people's expectations are mismatched a lot of the time in the enterprise. They think that it's virtual machines on demand. They think they can download some open source software and just basically spin it up, and then they've got, something between AWS and VMware that just works.
That's cloud.
That's cloud. And then you've got this sort of like whole DevOps kind of like application architecture change that is, I don't see any way for the average enterprise developer to get there except using PaaS, because they're just not going to become sophisticated at building scale out applications. And I teed you up, not actually.
So I think
She mostly
you
agreed
said
with me, by the way.
Yeah.
Mostly.
So I think you said two things that I'm not sure that I agree, but I'll repeat them to make sure if I agree on. One is that application needs to change to actually run on the cloud.
Not to run, but
To run well on the cloud.
to take full
Take full
advantage of
Okay.
the cloud.
Okay.
Yes,
That's good. Okay, that's a good observation. So we might be more agreeing than not agreeing. And the second point that I think you make is that the actual guys on the infrastructure itself is a moving target, and it's actually still going to be there over the course of the next coming years. And I actually tend to agree with that. And the question is, what do we do with that? What do we do with that? And I actually say this is accepted as a reality. The infrastructure is not going to be stable. There is no button that is fast forward on maturity, and that's not going to happen. And the next coming years is going to be continuously changing technology on the infrastructure. Embrace it. How do you embrace it? Decouple from it. For example, don't try to latch the application too tight into the infrastructure. In that case, you're going to have two things that are going to be in a collision course, and they're never going to match each other, and therefore you're never going to be successful. So by decoupling it, you let the train of the infrastructure to evolve, while the application can latch on new versions, etc. That's true also for purely OpenStack with the different releases that breaks one another. So to your point, I think that this is the reality, and the reality, the answer for that, don't wait for it to be stable, embrace it as an unstable environment. And the point about the application, if you really look at the application or the service that is most popular in the cloud today, you know what it is?
I'm dying. I'm
MySQL.
There we go.
Okay. MySQL was written where? Like 20 years ago. Was it written for cloud? No. Was it written to actually run on a cloud? No. Still, it's the most popular. So the thing that I'm trying to kind of take, and that was actually a lesson for me, because when I looked at that, I said, when I looked at what Amazon did with RDS, I said, what the hell? Do you actually need to shut down to upgrade? And the reality is that most people embrace that. And I said, well, maybe I'm wrong. And yes, I was wrong. There is more pragmatic way in how you could embrace cloud and the ROI of cloud than looking at it from a topical kind of point of view, where you look at the full value and say, if you don't embrace the full value, then you're probably not a cloud. And yes, there are a lot of gray areas in there. You could actually get a certain degree of automation, and automation for some people, especially those that are using MySQL, is to get and spawn a new version of MySQL in a few minutes, even if there is a downtime, is a huge value.
Yep.
And if you could automate the entire deployment and failover of that, that's a huge value. Yes, it's not highly available continuously, and so forth and so forth. So if you take a more pragmatic approach to that, then you have better chance that you could succeed in your cloud, because there is no way you could change all your application at one day and all of a sudden they will become cloud ready. And you don't want to wait for that to happen as well.
So
I'm not sure if we agree or don't or disagree, but at least
It's interesting. So I agree that overnight, I'm not aware of any enterprise that can automatically change the way all of their applications work. At the same time, you have to start somewhere. And if your starting point is running MySQL up on Amazon, maybe that's a starting point. It's certainly not a point I would start at. In fact, that's probably one of the last things that I would look to do. Certainly something that people can do, but I think it may indicate more of a lot of misguided people just trying to quickly solve a problem, which is more the startup mentality of you just need to put it together so it works, versus putting it together so that it's architected well, so that it can scale out well, so that it can deal with failure, so that you can upgrade without downtime, so you can do all of these other things. Architecting and writing your application to do that is something you have to do. But I agree, there's no enterprise that can do it overnight. We're working on doing that right now at Warner Music. We are in the process of greenfielding and literally moving entirely away from our classic IT architecture. But it's a many, many years process. And at the same time, you cannot, many applications, it is purely with a rewrite. In fact, I would say 99.9% of all the applications we will either reinvent or rewrite or port by rewriting. It's not something that you can just go, oh, well, you just move this over here, you move that, and put your web server here, and you're finished. There's a high degree of knowledge you have to have of all of these what I'll call cloudy design patterns to be able to do this. So that's why I think it's a long ways off before people will really be able to take advantage of this. Alex?
I listened to this discussion, and I'm concerned that we are taking an angle which is mostly a technical angle. And you know, when I think of cloud, I don't think it's a technology. In fact, if there's a parallel,
It's an attitude.
well, it's a law of economics, right? And so I think the parallel that we should probably look at is the Moore's law. Moore's law is essentially a law of economics that describes the way people are able to innovate in like semiconductor space. And so it kind of gives you a innovation curve, and those companies that are able to innovate faster and change faster than the curve become Intels, because their whole business model is to be one generation ahead of Moore's law. And those who can't, they're no longer with us. Fairchild Semiconductor, remember those guys? And those who are on the curve are actually still around. So cloud computing is essentially a law that says that your cost of ownership, your efficiency, your agility will actually change, will increase year to year to a certain percentage. And there will be some enterprises who will figure this out and they will change. Some will be ahead of the curve and they'll grow. Some will be behind the curve and they will disappear, and others will take their spot. But it's an economic law that will happen. And I think the drivers for having this done, and Warner Music is a great example of that. You do that because you have to change your organization. And for the net new applications that are stateless and scalable, you do it right away in the Amazon model or OpenStack model. For the others, you take advantage in DevOps and in development and testing environments, and through that you learn to do it, and that knowledge becomes something that others piggyback off of on the next generation of your enterprise application. And we see it left and right. And the ability of people to learn by just taking what they have in development and just playing the new cloud has tremendous human knowledge that then can change the enterprise. And I think that's a bigger driver than even the technology.
Yes, but I think it's a little bit misleading to characterize cloud computing as an economic model, right? That's like characterizing, power, utility power as being about, metered billing of your power. No, there's a whole bunch of technology that makes sure that when you plug into that light socket, you get some electricity, and it's non-trivial technology, right? It's extremely non-trivial, right? In some cases, things like nuclear reactors, right? I mean, these are things that are very highly technical and that allow for that business model to exist. So you can't really decouple
So is Moore's
sort of
law.
that.
It's very technology
You
centric, right?
can't, yeah, but you can't, you can't call cloud computing an economic model. That's just not fair. You could say that there's an aspect of cloud computing that's an economic model that's critical to understanding how to get competitive advantage and stay relevant, and I think that's fine. You just can't, hand wave the technology and say it's not about technology, because there's very critical technology aspects to it that are part of what allows us to get to that sort of business value that you're highlighting.
But I'm not disputing this. I'm not disputing this at all. And when I say it's akin to Moore's law, there's a lot of very, very complex technology to get to from 28 nanometers to 21 nanometers. And it's probably more complex than the things we're talking about in the cloud computing space. But yet the law says that we as a human race are able to change that technology with a certain speed and adopt this technology with a certain speed. So I'm not refuting technology at all. I'm just saying that embracing this technology has to be happening by us at a certain speed. That's the
Agreed.
economic aspect of it. So I think we're saying the same thing.
Okay. Yeah, so I wanted to kind of go back to your point there. How do we actually, what's the right approach to actually move the application to the cloud, and how is that related to OpenStack? And so we had this meeting with Bank of America this week, and Bank of America, for example, have 7,000 applications. The question that came out of that meeting was, how are you successful where a lot of other people on the street are still waiting around and you were able to move faster? And that comes back to, I think, both the economical model and the technical aspect. What's the worst case scenario? The worst case scenario is that you build a cloud like most people, and I call it the infrastructure as a service first approach. They build it, they have a very flashy kind of environment with a lot of flashy lights, but then they go to the application guys and they're saying, well, but that's not what we want. And then they start and they're doing second generation cloud, third generation cloud until they figure it out. That's the worst case scenario. Okay. The other worst case scenario is that you're waiting for all the applications to be ready. And that, as you mentioned, even in your case, would be a lot of years effort. The best scenario is that you get whatever you have there. The first thing that you do is just throw it, get it there, first of all. What you'll find in that process is that, one, you don't necessarily need to rewrite all of them because some of them will die. Well, actually, the majority of them will die naturally. So it doesn't even worth the effort to rewrite them. The new one will replace them, but won't be even a rewrite. It will be just new application that will come along. But you do that after you bring them to the cloud, not before that. So the pragmatic approach in that case is that if you want to maximize your ROI of that investment, get as fast as possible all the assets that you have into that new investment, because the worst case scenario is running those two parallel environments, and the longer you have those two parallel environments, the worst case in terms of cost and operational cost and knowledge and transition, all those sort of things is the case. So that's kind of the pragmatic approach that I think Amazon has shown us in many ways that they've been doing. I mean, they've been taking a very, very pragmatic approach to the things that they've been doing, and they've been even breaking their dogma in certain cases, and I'm sure that will come also with private cloud soon after they did the CIA deal, when they see a need for that. And I think that's the main lesson, is that you need to take a much more pragmatic approach to clouds if you really want to be successful, because the reality is going to be that the infrastructure is not going to be stable, and applications are not going to be written to cloud in one day.
So I should take my AS400 system with COBOL code on it and throw it in the cloud?
Well, don't take it to extreme. There would be application that
You said I should throw everything onto the cloud as quickly as possible.
Everything's had the heirloom computing will do it for you. So people are considering it, believe it or not.
Some people use drugs.
Are you saying you've never used drugs, Dave? Can I get you on record?
You can't get me on record on that.
So no AS400 and no mainframe. So,
Sure.
Yeah. So I'll put that outside, and that would require.
All my Access databases and Excel spreadsheets, I should put those on the cloud right away?
They could be on the cloud right away.
Some questions from the audience?
Yes, question.
Many times in my career, as I've been doing work in PC land, like I had a long career in identity management and LDAP, and the old mainframe guys were looking at me saying, "That's a lot like what we do in mainframe."
Yeah.
And then when we got into virtualization, they're like, "Wow, that's a lot what we do like what we do in mainframe." And I was wondering, and these APIs seem to have, I don't have any experience with an S390 now as a series myself, but I'm wondering if you guys have heard or had experience with cloud-like aspects within the mainframe land, and then larger questions like orchestration in the mainframe and managing workloads in mainframe that we might be able to learn from. And when we look at heat, when we look at different aspects of what we're building in OpenStack, to get a little the benefit of hindsight.
So the question is, are we going back to the mainframe?
Yes, we are, but how well? And maybe we can anticipate it this time instead of having the mainframe guys say, we already did that.
No, we're going to go head first right back to it. Don't be surprised.
I don't think we are. I mean, I've seen this argument before, and you know, I wish I had my diagram for this that I use. You know, kind of like here's mainframe computing era, here's enterprise computing era, here's cloud computing era. You know, if you look across that, there's stark differences, right? I mean, we're not on proprietary big box hardware anymore. We're on a bunch of distributed commodity hardware boxes, right? The software architecture is distributed. We're highly dependent on the network for communication system. You know, the high availability happens in software, not so much in hardware anymore. And you could just keep going on and on. But there are aspects that are similar, but that's just because, you know, there's only so many tools in the IT toolbox. We can pretend like, you know, it's infinite, but it really isn't, right? I mean, there's so many ways you do networking, so many ways you do storage, you got spinning disks, you got flash, you know, and so you just revisit a lot of the tools in the toolbox as IT evolves because there was a good idea. Virtualization on mainframes was a good idea, so it gave VMware some ideas, and so they ran with it. But it's different each time. It's not a revisit, it's just a re-information.
I think the answer we're searching for is that, and then I'll let you ask your question. I think the answer we're searching for is originally when we had mainframes, the hardware was really, 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 really expensive, and it was hard to get a hold of. And so you were constrained by that and the size of the hardware, frankly, because it was huge. You're certainly not going to put a mainframe under your desk.
It's a scale-up pattern, right?
Yes, it's scale up, but it's also back to the whole economics discussion. It was damn expensive to get a mainframe.
As all scale-up solutions are.
Yes, and so we saw the minis, and then we saw PCs. But it was even in the x86 era originally, it was still really expensive to have servers. When we were building the MySQLs and the DB2s and the Oracles and such, when they were first coming out, all of the hardware for that stuff was still really expensive. So really what you still had were scarce resources. They were less scarce, but they were still scarce. Now, following Moore's law even further and further on, when we talk about distributed systems, it's because we no longer have a scarcity of resources, we're seeing an abundance of resources. And so because we have that abundance, we can take advantage of different properties based on the abundance. And that's really where I see the differences coming, and that's why we'll be able to treat and behave differently, is because there's an abundance, right? More and more cores, more storage, more memory, and so...
And be more wasteful.
We will. We will be more wasteful, just like we are with electricity, by the way, if we go right back to the paradigm a dozen people have written about. But we're going to use it in different ways because of that, and we'll find new uses that we would have never thought of or found had it still been such a scarce resource. And you had a question, sir.
Well, I was just going to say, I've actually done automation on the S390s using Opsware. The LPARs are not terrifically different from the idea behind an LXC in terms of partitioning a resource.
So it's a Docker.
True. It's totally feasible, but the reason why people buy mainframes even in today's day is because of the scarcity of resources. It's in a data center, the two scarce resources are power and cooling. And an S390 in some cases can actually be a better option than going out and buying cheap boxes in terms of the overall cost, because you leave a cost up front, but the long-term cost could be a savings.
Especially for high I/O kind of workloads, right?
True. But I've seen a lot of people using those just as VM houses.
Yeah, I think that the fundamental difference, in my view, that cloud assumes that drives a lot of the cost also is that failure can happen, and it's just statistical, whether it's high-end machines or low-end machines. And actually, there's been an interesting research, I think, for the first time that people did on storage devices. And one thing that came out of that is that the failure statistic was almost the same between the high-end disk and the lower-end disk, which kind of proved that the failure are statistical. The statistics happens all over the place, and therefore you need to design for failure versus avoid failure from happening. And the mainframe was really built from the concept that you could avoid failures by having a hardened hardware and a very high-end hardware with built-in redundancy between the hardware itself, but we all seen mainframe fails, and mainframe do fail. And that's the fundamental difference that also drive completely different algorithms in terms of the way you're doing orchestrations and some of those things. I would agree, though, that we as an industry are not doing a good job, and I think that will still be the reality of learning from past experience, because we're moving to a new world and immediately saying, well, whatever was in the old world doesn't worth anything, and we're just trying to and repeating errors of previous mistakes. I think that's the reality. Those who are building the new world usually are not the same guys that build the old worlds, and the knowledge transfer is not there. But that's the reality, and I think we'll probably do some mistakes that people have found out 20 years ago. Yep.
There's this guy who wrote an operating system called C that just finished writing an operating system called Go. And the problems that he solved in Go are like, yeah, and if I had been on the mainframe doing centralized identity, 35 years ago, I would have written that into the initial takes at Sun's identity management services, and it would have just been the solution that everybody used because it was right. I was wondering, my point was more towards the things that are now emerging from OpenStack, especially things like heat, and what we can learn from the past as we craft together. Because Tosca seemed to me like something that I didn't want to go near.
Yeah, so first of all, I think that there are a couple of things about Tosca that I'll touch on, but there are good things about Tosca and there are bad things about Tosca. I wouldn't, especially if you're talking about learning from past experience, I wouldn't rule out Tosca completely, because there is one thing very good about Tosca is that there is a solid definition of dependencies and a very fine-grained level. What is an application stack? What is a dependency between components in the stacks, and how do you describe them? So there's a lot of things that we can learn from Tosca and actually embrace them in OpenStack, rather than ruling that completely, because some areas looks very complex that to human being the way we are. So I think specifically on that since you brought heat and Tosca, I think that it would be the right thing to actually build the next version of heat, taking ideas from Tosca and building it in the right way within OpenStack. And in general, I think that the process of driving the next version or the future version of OpenStack is by looking at the experience of what others have been doing, Amazon, for example, and doing it pretty much the same or better, because probably they figure out a certain way that is working already. So why not learning from that example and implement that? And I think to Randy's points, we shouldn't look at Amazon or Google as a competition. We actually should look at that as a reference that we should not just interoperate, but actually embrace the good thing, not just obviously not the bad things, but at least the good things.
So we should recode it in Erlang.
Well,
Yeah, I always look at the sort of stack that people think of as an inverted pyramid with infrastructure at the bottom, then platform, then apps. And when I think about it that way, I think about reducing variability at the infrastructure layer, right? I mean, automation works when systems are homogeneous. That's why Google has 10 hardware configurations across 2 million servers, right? But then as you start to go up the stack, variability actually starts to be important, because the way you're going to solve a problem for .NET is different from Erlang, is different from Java, is different from a message-based architecture versus a database focused architecture. I mean, and there's valid reasons to solve all those problems using very different tooling. And so for me, I look at something like Heat, and I have a very simplistic view of Heat. I see Heat as being an application installer, right? Because say you've got Cloud Foundry or Prenda or some other PaaS solution, get it on your cloud. How are you going to get it on your cloud? You can't. They don't have an installer. But Heat could be a great lingua franca for how you install an app. Now, once you install a Prenda and you install Cloud Foundry, they have different mechanisms for how they drive the infrastructure, as they should, because they might have different requirements depending on the problem they're trying to solve. And so I don't think we have to normalize that platform layer at all. I think we need to allow people to solve kind of the infrastructure management layer, the platform and app layers in their own way, but we do need tools like Heat, like without all the Tosca baggage, to just do the simple bootstrapping of putting an app on, right? Or a stack on. I always think of Heat as more like a stack installer, right? And if you look at how they're using it in the OpenStack infrastructure team, they use Heat to basically install OpenStack on bare metal. And that's valid, right? I mean, that's what it does. It basically bootstraps other people's code, and then that code takes over and runs. I mean, that's how I look at Heat.
Okay. Question?
I don't know if anyone's ever used GE Radio, but GE Radio actually presents an interface very similar to something that HP created called operations orchestration. In terms of the idea orchestrating process flows both work fairly well. If you want to see how a functional process orchestration framework works, both of those demonstrate fairly well. I could see heat plugging in there.
GNU radio?
Yeah, it's used for radio stuff, for like ham radio, software-defined radio especially. So people define blocks of software-defined radio process logic. But what you see is a good way for visualizing large complex systems in small blocks and then interconnecting.
So it's sure. So it's basically like a flow-based programming or something like that. Where I'm trying to think of the one I saw recently, NoFlow, which does flow-styled patterns where you have different flows and you do transformations and such against these. I think it's used for doing things like ETL and data transformation. But it's the same idea of what you're describing, where you have these different blocks that do some different type of operation, and you're wiring them together into a flow.
Yeah, the comment that I have is that I think I hear a lot of discussions when we talk about orchestration that people bring a lot of the automation tools that they have, an orchestration tool that they have in an existing data center, and say, why not use that? And I think there is a fundamental difference between a lot of those tools to the one that we expect in the clouds. And I think if we touch on DevOps, one fundamental difference is that if you look at a lot of those orchestration tools is that they usually live in the operational world island. And for example, if I develop, I don't have access to that even. Only the operational guys will have that. And there is a fundamental difference to write a tool that will be friendly both for developers and for the operational. And that's why we're seeing, for example, again, it's not necessarily the right choice, but the Chef and Ops Code popular in both camps in the world because they're more API friendly, they're written in Ruby in a way that at least developers can feel a little bit more comfortable with that. They're not as good to that problem as much as I think they should, but still they're better than a lot of those existing orchestration tools. Another thing that is important, again, if we're coming back to Heat, is to look again what Amazon did. So Amazon had CloudFormation, and they had the PaaS layer, which is the Beanstalk. But recently, I think it was February or March this year, they bought OpsWork. I'm not sure if you're familiar with OpsWork. So OpsWork was kind of the third layer. Now you would ask why they had CloudFormation, like Heat in OpenStack, and they had a PaaS. So why did they add that middle layer? What was missing there? What was the void that they were trying to solve? And really, at the end, if you really look at all the trends that happens, at least on top of the stack, is that we have two main forces. One of them is control, and the other one is productivity or ease of use. And we're trying to kind of find the right balance between the control and ease of use. If you're going too extreme, like in Beanstalk, to an ease of use, we're losing a lot of control. If we're going too extreme to the control, it becomes too complex.
Well, it depends on the use case, though, right? I mean, some things want more control, and some want, more kind of things being baked. So it's
but the ideal scenario is that you want to have. I wouldn't say both because it would sound non-real, but you would want the trade-off not to be too extreme. And I think today, if you look at the CloudFormation, if you look at the Beanstalk, the trade-off is too extreme because in many cases I want the control and the ease of use, but not necessarily the ease of use that PaaS, say the regular PaaS, the Heroku kind of PaaS would provide me. So if you would give me a way to draw my stack and even plug into Chef or plug into whatever definition that would give me control over which VM it's going to run and so forth, then what do you use that?
I don't think there's one size fits all.
I don't think so at all, but I think that the two extremes that exist created a void in the middle.
Oh, absolutely.
And that's what I think OpsWork, and the question is how big that void in the middle. Is it small or is it very big? I think it's very big, and I think that's what brought Amazon to actually put something like that in the middle, which is not the pure PaaS, but it's not also the CloudFormation of the world. It's actually something different that gives the users the control, but with high degree of ease of use.
There's very little to add. I mean,
Okay.
we're very far from the Amazon API discussion.
Yeah.
We're talking about the future of cloud, really, not even OpenStack anymore, right? And what's interesting is that we're kind of doing exactly what I said we're doing. We're away from the actual infrastructure now, right? We're talking about how to make applications and users actually use this kind of stuff. And I think that's where innovation is moving right now, and that's the dialogues. And we're having this every day in our back rooms, because it has been about how do you make infrastructure bits and bytes work. And now that we're actually installing this and customers are starting to use them, there are all kinds of perceptions out there. So there are people who are trying to find management usage models for OpenStack clouds in the scale-out world, and that doesn't exist, right? So everybody is building their own solution, and we're trying to see, what's better. And what exists now is not very good. And then there is the other camp, which is the traditional people that have all the management infrastructure with PMCs and tools and all that, and how can we fit into that? And should OpenStack even go there, right? And so I think what Nati and Randy started to talk about is how do you actually tackle this problem? I think it's greenfield right now.
But that's where, at some point, there's only so much savings you can wring out of infrastructure and cloud versus the value you can add by providing different services and capabilities to the business, right? And so
I like to think of cloud as being all about adding new value. I think virtualization is about reducing your cost of ownership. I mean, the businesses
By the
I've
way,
been
I
talking
agree
to
with
this
you.
week, I'm sure that you do. The businesses I've been talking to this week, they're trying to create flexibility and speed inside the business. The way I think about this is like, if you look at a typical enterprise, they have all these smart people in there. And then these smart people are surrounded by this giant ossified structure that makes it impossible for them to get shit done, right? I'm only a startup guy, so all I've ever done is get shit done. So I can see this from the outside. But those people have good intentions, and that's why they go to AWS with that permission to get going on the project they're trying to do. And so if you want to allow those enterprises to move faster, to actually be able to be innovators, you have to empower the individuals and departments to basically get shit done without the ossification of the business basically holding them back. And I look at that as the primary value of cloud computing, right? And the way that you can see this, the seed of this came out of Amazon.com, right? Before Amazon Web Services, they got into a position where all their ops guys, they couldn't be trained on all the Amazon.com products.
Yeah.
There are thousands of them. How could they train the ops guys? So the ops guys said, okay, we're going to step back, we're going to build a framework, and the dev guys basically are responsible for their products in production. The developers are going to push buttons and push their code out without anybody's help. And that's what they did. They empowered all the developers inside of Amazon.com, and that was really the seed that germinated for a while and turned into Amazon Web Services. And that's the true power of cloud computing, is to unlock the value of people developing new applications and driving new value into the business.
I agree. I think the point I'm making is that if you look at most IT orgs in enterprises, they don't think that way today.
Absolutely.
They think it's all about saving costs. IT is a cost center. How can we cut costs? Can I deploy OpenStack to cut costs? Can I double virtualize to cut costs? What can I do to make the cost lower? Not about the value of the agility that if you operate on a cloud, you can get if you properly leverage it.
So this is a great lead in to the problem that that I think we ought to solve as OpenStack ecosystem. That's a conversation that Nati and I have been having offline, and not just just us. A typical use case that we see is we have application people who would love to see OpenStack and orchestration and development, everything kind of available to them in their application today. And to enable that, they know they'll need 6 months if they have the infrastructure. But to have the infrastructure inside the big enterprise, they need to have the infrastructure guys set this up, and they're scared, they don't know how to do it. It will take them 2 years in the traditional enterprise setting to actually get this done. So you say 2 years plus 6 months, so I guess in 2.5 years, maybe we'll get the enterprises to start adopting. So the question is there a way to shorten the path? Is there value we can bring to the application guys today in the auspices of the enterprise that will actually allow them to use it today? And whoever can unlock this problem, will be the first IPO of this crowd. And we've seen this happen with Apple revolution, right? 5 years ago, you go to a meeting, and most people will have Dell machines and IBM, compatibles, and there'll be one strange dude with an Apple machine. You go to a meeting today in a crowd like this, 80% is Apple machines. How does, and they're all working for large enterprises. So Just one day overnight, I work a lot with Cisco. One day overnight, I noticed that every Cisco engineer is kind of carrying, and marketing guy carrying the Apple thing. So the question is, how do you guys do it? Because you have to be supported by the IT organization. Well, the IT organization kind of is not supporting Apple and Cisco, but what they did is they kind of said, well, because there is such a groundswell of demand, we'll just do a deal with Apple stores, and everybody will do a self-service of that thing, and you can just do whatever you want, and boom. Suddenly 80% of all people in Cisco are actually using Apple. Now try to sell it in the IT organization, they'll still be talking, right? So if we can figure out a way to go directly to the users and sell them the value, these guys will jump,
That's called
but
AWS.
how do you unlock it?
That's AWS.
No.
You just described AWS.
No.
The value.
AWS figure out the infrastructure first, and then the application came in.
They created the
so they have
demand.
a luxury that I think most enterprises don't
No,
have.
you have a SaaS developer that can write an app easily on AWS, right? The startup.
Because
and
the
he
infrastructure
sells-
exists.
In the
Right, and he
auspices
sells.
of the enterprise, you can't do that.
Developers inside the enterprise all the time are writing apps up on AWS and then going to the business user and going, here's what I wrote. And they're going, wow, this is great, and they start using it. And at some point, IT catches wind, and that's when all of a sudden problems occur.
So I want to touch on that because I think that's kind of, in my view, the main thing that I see as the obstacle of enterprises adopting cloud. Should we wait for the infrastructure to actually make the application cloud-enabled or leverage cloud? And I think there are various ways, and you mentioned that here is a way to do an IPO. I think we'll figure at least part of that out, is that you don't necessarily need to wait for the infrastructure to be in the cloud per se. One option is to bypass the entire IT and go to Amazon and at least start there before, and don't wait for the infrastructure. And once the infrastructure is there, you could route the application back into your own IT. That's one option.
That's 10% of what they
Yeah,
can do.
exactly. And the other option is to say, what do I need to do to make my application ready for the cloud? Do I actually need to have a cloud to make the application ready for the cloud? And my answer is that you don't necessarily need to wait for that infrastructure to be cloud to make your application ready, because what you need to make it ready is make it elastic, make it something that could be deployed automatically, and that the way you configure it will be automatically, the way you deal with all the failure scenario will be automatically. None of that is really requires the fundamental requirements that you have the underlying infrastructure as a cloud. Obviously, if you have a cloud, it helps. But up to a certain degree, I can even take a pool of bare metal machines and write my application in an elastic way, but within a predefined pool. So my point is that you could definitely run and cloudify your applications in parallel to the process that the IT needs to take its infrastructure to the cloud. Whether you bypassing the entire IT or whether you cloudify it and by decoupling your application from the IT in one way or the other, you can move in parallel path. Only when you move in parallel path, you could actually converge much faster, as I think Alex was talking about.
That will, I think
The
that will
reason how
solve.
many developers are thinking to do that is my question.
That's the problem.
developers.
So I would say that at least in the street, most people don't think in those terms. Most of them. That's why they stop. And in the case of Bank of America, I think that was the first time that I've seen someone who's actually thinking about that, because they actually created a group, which is an open source group, and they embraced some ideas from the outside to actually do that. Most of the organizations are getting with this infrastructure first because they think that once we'll get the infrastructure and it will be stable, then we'll bring the application. But it will never be stable. At least not in the next 3 years, it's not going to be stable. And then even within the organization, there's going to be the high performance cloud, and there's going to be the consumer cloud, and that's going to evolve, I think, twice, by next year. And that's going to be the reality, and most people don't yet realize that, and they don't think about it in those terms.
I think Alex really wants to say something.
Yeah, so I think I agree with the approach on cloudifying. I think it's the right approach to parallelize those two, but I think it will not solve the problem dramatically, because it will still take 2 years for the Bank of Americas and Morgan Stanley especially build this. So even if your application ready, you still have to hurry up and wait. And that means that the value proposition for the application owners will not be there, and therefore there will not be the power behind their will to do it. So there has to be a way to create a hybrid solution, whatever that means. I have some ideas, but I just speak at this level of abstraction, where you can take your Cloudify idea and couple it with other infrastructure solutions which are generic, that could be built into something that the enterprise can embrace today. And whoever figures out that thing will be able to recognize this value in the time it takes to cloudify an application, which is probably a 6 months period, and not have to wait the 2 years. And that will create competition for the IT guys who will say, hey, these guys figured this out, we better, go with the program or else we'll be out of work tomorrow. And, the speed of adoption will actually increase. And we have some ideas of how to do this, but if somebody can figure it out and kind of, create use cases for that, I think will greatly, greatly speed up the adoption of this thing in enterprise.
Questions? We're just sped up anyway.
Questions,
Yeah.
comments, pontifications?
Yeah.
Somebody else?
We've got about 5 minutes.
We can wrap early.
Yeah, well, if there are no more questions, then thank you very much.